Welcome back. Week 10 again, the second video that's been published this week. And as I said in the previous video, this week is all about adding and subtracting fractions once again, but this time with different denominators. Now this week, this video today is probably one of the most valuable videos you will watch, okay? These question types, you're probably looking at 5, 6, maybe even 7 questions about fractions with different denominators. So they are so important to master and understand exactly what it is that we're doing. And ultimately, the process is very, very simple. All we need to know is our times tables and how we apply our times tables to fractions, okay? So it's nothing to worry about, and it's once we've practiced it, it's a really simple strategy to carry out using your times tables to help you adjust the fractions so that the denominators become the same. So essentially when we get into the teaching, last week's video was all about adding and subtracting fractions with the same denominator. That's what we want. This week's video is about adding fractions and subtracting them with different denominators, what we don't want. So it's all about how do we get them to the same denominator. And that's exactly what we're going to cover now. So let's get straight into this week. Now this video is probably one of the most important videos because this video is worth somewhere between 3 to 6 marks in your arithmetic paper, because in most of the papers there are at least 3, at most 6 of these question types in the test. So long division and everything else, great. There's 4 marks available there and there's a lot of work. These are relatively simple that we shouldn't be getting wrong, that are going to guarantee us 3 to 6 marks in the paper. So it's really important with these fraction questions. And the bit that we've got to think about, the reason why people get these wrong is we just get mixed up between what strategy we're applying or what question related to fractions it is. So I've always got these key little prompts to try and help you. So in the last video about adding fractions, adding and subtraction with the same denominator, these are different. The same denominator, that's just a green light, isn't it? It's a green light to go and just do the addition and subtraction. But my prompt that I always want, as soon as you see a fraction question, what's the problem? And we're always looking at the denominators. The denominators are where basically the action happens. It's going to decide. And I'm going to color these differently. So we're going to color these red. So in the last video, it was green for go. The denominators are the same. Let's go. Let's just add and subtract the numerators. Now, red light on this one, we're looking at the denominators straight away. The denominators are different. So that means we need to get them green, okay? So the whole strategy here is about how can I get these denominators to be the same, and we're going to rewrite it down here so that then we're in a situation for green light and we can just add the numerators, because that's what we're looking to do. Can we get in a position to add the numerators together? All right, so basically the strategy is we're going to concentrate on these 2 denominators. Now, the first thing that we need to do is get into your mind that you're going to rewrite this problem. So as soon as you see this, I like to work below, is we're going to rewrite the problem. So I'm going to put my 2 fraction bars in there. Just going to get a black pencil up. 2 fraction bars, add equals add. So I've basically set myself out for working below, because everything up here is going to transfer down into here, okay? So this fraction is going to end up down here. This fraction is going to end up down here. And it's just how we write it. With practice, we can just write this out and get the answer very quickly. Now, we need to focus on getting new denominators. And to do that, we need to find something called a common denominator. And you'll have heard of that before. And all a common denominator is basically a number that a number that these 2 numbers have in common in their times tables, the multiples of these numbers. So what you'll have been taught in the past is to write out now this is the bit that we need to get past, but to write the times tables out and to find the common denominator. And we'll do that so we can visually see it. So for the 3 times table, the 3s, you could say 3, 6, 9, 12, 15. Now, I'd only recommend in writing the first 5 out. Some people will say write the table out. That's a waste of time. In the arithmetic test, we haven't got that time. 4, 8, 12. Now, I'm not even going to go past that, because that's the point at which we should see a common number, a common multiple that these 2 tables share, which is 12. Okay? And to get to that, we've had to essentially do 3 times 1, 3 times 2, 3 times 3, 3 times 4. So we're timesing by 4 to get there. And this one we've increased by a factor of 3. So we've done times 2, and that would have been times 3, wouldn't it? 4 times 3 is 12. So that's important in a second. But essentially, we've got this common denominator, this common multiple that we can use. So now we've found this, and again, you could have looked at these two numbers. If you know your 3 times table and your 4 times table, in your head, you should just be able to go through and think, yeah, the number's 12, isn't it? 3, 6, 9, 12, 4, 8, 12, 12. So we're going to write that down here. So this is our new denominator, 12, 12, and we can even put it in the answer ready, okay? The key now is to think, right, well, how I've changed my numerator, my denominators, so we're going to put them, we'll leave them red for now. Oh, let's get rid of that. In fact, we won't. Let's highlight these green because we're getting this in a position to go. So these are now green because we've got them the same. But we need to adjust the numerators. Okay, we've essentially multiplied, as we said here, look. We've multiplied 3 by 4 to get to 12. 3 times 4 is 12. So we need to do the same to the numerator. And I always draw a little line. So essentially, what we've done here is times 4. So we've multiplied this fraction by 4. So we've multiplied this by 4 to get to 12. So we need to multiply this by 4 to get our new numerator. So 2 times 4 is 8. Very, very simple. And again, we're going to do the same on the other side. How have we got 4 to 12? Well, essentially, we've times by, if we look over here, we've times by 3, haven't we? Okay. 4 times 3 is 12. So I'm just going to make a little note, times 3. So again, we're going to do, we've done 4 times 3 is 12. We're going to do the same to the numerator. 3 times 3 is 9. Very, very simple. Now we're in the green go position. Denominator is the same. We've got our new numerators. We just need to add them together. 8 add 9 is 17. Okay, 17 over 12. That would be the correct answer. You could put that in and get the mark. Now, ideally, we would want to convert this to a mixed number. Okay, we covered that in the last video, but essentially we're going to say how many 12s are in 17? Well, there's 1, isn't there? Because if we go through the 12 times table, we'd have 24. So that's no good. So we'd have 12. So that's 1 whole. And then the remainder between 12 and 17 is 5, isn't it? So we'd have 1 and 5 twelfths. So this, you could put this in and you would get the mark for that in the SATs. But as I always say, it's great to be able to convert improper fractions like this into mixed numbers and vice versa. It's a good skill to have. But essentially, that's all we're doing. So we're looking at this. We're seeing the fact that we've got different denominators. So that's our red light to find a common denominator. You can write this type of thing out at the side. You've got space to do it in your SATs. But ultimately, we should be able to look at 3 and 4 and think the common denominator is 12. And the more you do of these, the better you'll get at it. If I said if the denominators were 2 and 5, hopefully you'd go 2, 4, 6, 8, 10, 5, 10. So the common denominator with those two numbers would be 10. If the denominators were 2 and 8, the denominator would be 8. If the denominators were 5 and 7, if you went through both those times tables, the lowest common denominator would be 35. Okay, 5, 10, 15, 20, 25. And the 7 times table is a bit of an awkward one, so you know you're not going to match up very often. So that's the strategy. Let's have a look at another question. So let's do this one a bit more like we would. All right. Straight away into the question, we're spotting that the denominators aren't the same. So I'm going into autopilot and I'm writing the question out below just to give myself a bit of breathing space to lay this all out properly. It's a quick addition. Now, my first thought is denominators, okay? Hopefully you're looking at 4 and 6 and you're seeing 12 again as the common denominator. So we're not just, a lot of people will just say times these together. The problem with that is it will sometimes give you a larger denominator, and we want to work with the lowest. If you did 4 times 6, you would get a common denominator, which would be 24, but that, when it comes to doing the question, that would make these numerators larger. So we always want to try and get the smallest one as possible. So if we quickly wrote them out, 4, 8, 12, and then 6, 12, we can see straight away that our common denominator is 12. All right, now once we've got that, we can just basically get on and do the question. So this is 12, this is 12, this is 12. How do I get 4 to 12? Well, I've times it by 3, haven't I? 4 times 3 is 12. So I need to times the numerator by 3. 2 times 3 is 6. Dead simple. And then the same on this side. How have I got 6 to 12? Well, I've times it by 2, haven't I? Okay, multiplied it by 2, so I need to multiply the numerator by 2. 5 times 2 is 10. Dead simple. We're now in that green scenario where we've got everything that we want, so we can just go ahead and add 6 and 10, which is very obvious, which is 16 over 12. That would get you the mark. Again, if we're going into converting, because this is an improper fraction, this is an improper fraction because the numerator is larger than the denominator, you would get the mark for putting this in. But how many 12s are in 16? There's clearly 1. Whoops, get my pen out again. There's 1 with 4 remaining, isn't there? So if you count on from 12 to 16, that's 4, and we're working with 12s, so it would be 1 and 4 12s. Again, that would get you the mark if you put that in, okay? But the improper fraction works. So again, very, very, very simple. Key thing, denominators are different. Work out the common denominator. If you've got to write them out quickly, write them out. Hopefully you can just see that it's 12, 4, 8, 12, 6, 12. And then get on with rewriting the question below. Rewrite the question, just get into that habit. And again, this is going to be the same for subtraction. We're going to highlight it off just so we're in red position now. We look at this question and we see that with 6 and 5, they are different. So we're going into autopilot mode. And this is the beauty of it. We shouldn't really be, sounds a daft thing to say, shouldn't be thinking about it too much. Just drop into the strategy. What's the common denominator of 6 and 5? Well, in my head, I'm thinking it's going to be 30, but we'll guarantee that. 6, 12, 18, because 5 times table's obvious, isn't it? 24, 30. And then again, 5, 10, 15, 20, 25, 30. So the lowest number that we encounter in both of those tables is the number 30. Let's get some green on there. Is the number 30. So that is going to be our new denominator because we can work with that. So that is 30, 30, and the answer will be in 30ths as well. So again, dead simple. How have I adjusted 6 to 30? Well, I've times by 5, haven't I? 6 times 5 is 30. So I need to multiply my numerator by 5. So 5 times 5 is going to be 25. You can see how you could do this quite quickly without all my explanations. And then over here, we've got, how do I get 5 to 30? Well, 1, 2, 3, 4, 5, 6. 5 times 6 is 30. So again, it's times 6. And I'm going to times the numerator by 6 as well. So we're doing exactly the same to the numerator and the denominator. So 1 times 6 is 6. Okay, just change the color again. So again, we're then just going to go ahead and do 25 take away 6 because we're in green position. Green is great. Our denominators are the same. We've adjusted the numerators correspondingly, and we can just do 25 take away 6, which is 19. And this is a proper fraction because the numerator is smaller than the denominator. So if we had a blue answer box, that would just get written in as 19 over 30. And that's it. Dead simple. Okay, the key thing is just as soon as you see a fraction question, he's going, which strategy am I using? Denominators are the same. Great. Green. Go. Just do it. Denominators are different. Red light. We need to get the common denominators. And then we need to rewrite the problem just for clarity. Okay. Again, one other example. So again, just to make this really obvious, denominators are different. So I need to go straight into my other strategy of 7. And hopefully you can see that it's 14. And yes, if you just did 2 times 7, that would give you 14. But we want the lowest one all the time. So we've got 7, 14, 21, 2, 4, 6, 8, 10, 12, 14. All right. So again, I'm not advocating for writing these out every time. If you need to write them out every time, do it, but just do it quickly. Just get in and write them out. Don't write the whole table out. Just write the first 3 or 4. If there's not one there, write the 5th and then the 6th. You should find it by then, okay? So again, we know now that we've got 14. So again, it's complete autopilot. So subtraction equals, we're working with 14ths, which I'm really happy about. So we can just get that written in. How do I change 7 to 14? Well, it's times 2. So I need to times 6 by 2, which is 12. Very simple. How do I get 2 to 14? Well, I've times by 7. I'm going to do the same with the numerator. So 1 times 7 is 7. Very simple. I can now in green light position, and I can do 12 take away 7, which is 5. So I've got 5 over 14, and that would give me the answer. So again, really, really simple. And again, it's just spotting the key clues. Denominators are different. Drop into the strategy. Common denominator. Rewrite the question below. Adjust accordingly. Do the question. Very, very simple. And you will get the answer every time. And essentially, those there are 6 easy marks in the test. The only other one to look out for is when we have the denominators are different. And I've highlighted this in green, because essentially this 6 is already ready to go, and I'm going to show you why. So this is the only other little variation that you're going to encounter. So currently we've seen this question and the denominators are different. Fantastic. But really what we should be looking at is just thinking, well, I know that 3 is in the same times table as 6. So we don't really need to do that much work. All right. Essentially, the common denominator is going to be 6. So this fraction doesn't need to change, but we're just going to adjust this one so that it is 6, all right? Because if we wrote both the times tables out, we've got 6. Let's do it here, and then we've got 3 and 6. So the lowest common multiple in both of those tables is 6, all right? So when we rewrite the question below, which you may still want to do, it's just a good practice. Take away equals. If we know that 6 is the denominator that we want to work with, this one is already 6. So I don't need to do anything with it, okay? This one is, so how did I get 3 to 6? Well, times by 2. So I need to times the numerator by 2. So that is going to become 2. 2 times 1 is 2. And then we're in a position, we're in green light position. We can just go ahead and answer the question. 5 take away 2 is obviously 3. So we've got 3 over 6. Very, very simple, all right? So if you get these situations where one of the denominators, if you work the common denominator out and it's already one of the denominators, like for example, if you were subtracting 4ths and 8ths, straight away, both of those are essentially in the 4 times table, just like 3 and 6 are all in the 3 times table. Okay, 4 and 8 would be the same, 5 and 10 would be the same. So 10 would be the common denominator. The larger one would be the common denominator. So don't get caught. Sometimes that confuses children and then they start doing all sorts of weird multiplications. Essentially, if the denominator that you end up choosing is 6 and that's already one of them, then that fraction just remains the same. It's already a 6. You don't need to do anything to it. You just adjust the other fraction and then do the problem. So we'll probably get some of them in these SATs examples, and I've got quite a few to show you because this is a really important area and I want you to see these questions answered. So again, at the start of each one of these problems, I would suggest you pause it and have a go on your own paper and then watch me go through it. All right. So if I was doing this, again, the first thing that we're spotting is that the denominators are different. We're not going to obviously highlight them off, but as someone who's answering this question, it's question 24, it's quite far on the paper. So they're expecting you to have to do a little bit of work, okay? Half add a 5th. Again, the denominators are different. Hopefully you're spotting that 10 is going to be the common denominator. Now, if you needed to write it out, you could do that anywhere on here. I would do it out the way where there's a bit of space. So you've got 2, 4, 6, 8, 10, 5, 10. So straight away, we can see, if you need to do that, that the common denominator is 10. So then I'm going straight into autopilot mode. And it doesn't matter too much about how you lay these out in the boxes. They're just there if you need it. I'm going to do it a little bit larger than I would just so you can see it. All right. So ignore the squares a little bit because I just want you to be able to see. So I would be sort of writing 1 over 2 add 1 over 5. That's the original question. It took me 6 seconds to write it, so you're not losing time. I'm then rewriting the question below. I know my common denominator is 10. I'm giving myself space to work in. How have I multiplied 2 to get to 10? Well, I've multiplied it by 5. So I'm going to multiply 1 by 5, which is 5. How have I got 5? How have I got 5 to 10? Well, I've multiplied it by 2, haven't I? 1, 2. So I'm going to multiply this by 2, the numerator by 2. So times 2. So 1 times 2 is 2. Very simple. We're now in green light position. We can go and do 5 add 2. 5 add 2, very simple, is 7 over 10. Okay, we need to make sure that we write that in here. Job done. We've got the mark. Now, again, with me doing that and lots of explanations in there, it's probably took about 20 seconds. Okay, so you have the time. You have the time to write this out. You really do. And you have the time if you just spot that the denominators are different and you get straight into it, you have the time. Okay, so 7 over 10, mark, done. Let's do another one. Again, question 25, so quite far on in the paper, a half add a third. So again, hopefully we're spotting that 6 is the common denominator. Again, I'm just going to do it 2, 4, 6, 3, 6. Okay, so the two denominators were 2 and 3, so we do the 2 times table and the 3 times table, and very quickly we see that the denominator is 6. So we go straight into autopilot. I always like to write the question out again. Okay, so we've got a half add a third. And again, that just helps me work through the process. So I'm then, and I always like to, it's probably good for me. I like to think from a child's perspective. It's very me. So again, we know it's 6. So I'm going 6, 6, 6 as the denominators. And then I'm thinking, right, how did I get from 2 to 6? Well, I must have times by 3. So 3 times 1 is 3. And this is, I'll finish the question and I'll go back to that point. And then how did I get from 3 to 6? Well, that's times 2, isn't it? Very simple. 1 times 2 is 2. We're in green light position. 2 add 3 or 3 add 2 is 5. Again, so very simple. 5 over 6, that's the answer. And again, what I was going to go back to is that when I'm saying this, what's 1 times 3 is 3 and 3 add 2. The numbers that you're actually working with are the first numbers that you ever learned to work with, 1s and 2s and times 2s and times 3s. It's very easy. The maths that you're actually doing is very, very easy. It's the easiest it could be. The only complication is just knowing what this question is actually asking you to do, which is add a half and a third. How do we do that? We need to find a common denominator. So really, it's the technical bit that you're learning. There's no maths really involved that takes any thought. Okay, so this is why the strategy is so important. All right, so again, that was an addition, very simple. Let's do another. So straight away, the difference here is, again, it's question 17 in a paper, but again, we've got a much larger denominator here. Now, again, hopefully you're spotting that 7 and 21 are in the same times table. So that gives us one of those situations that I covered before, where one of these fractions are going to remain the same. This fraction is going to remain the same. Because when we write these two out, because 7, 14, 21, when we write these two times tables out, we're going to see that it's 21. And this is already 21, so we don't need to adjust this fraction. So just for the sake of it, 7, 14, 21. And then if we wrote the other times table out, 21. Because we don't know the 21 times table, we can get the first few. So essentially, if the denominator is already 21, we don't need to adjust this fraction. We just need to adjust this fraction. Brilliant. Let's go straight into autopilot. Write the question out. 5 over 7, add 3 over 21. See the space that I'm using below. 21, 21, 21. Now, I know that this fraction is going to remain the same. It's already 21. As a denominator. So I'm just going to write that numerator in now. So that one's done. And then again, over here, I'm thinking, how do I get 7 to 21? Well, it's times 1, times 2, times 3, isn't it? Times 3. So then I must multiply my numerator by 3. 5 times 3 is 15. So then we're there. All of a sudden, what looked like a complicated question is very, very straightforward. And we're going to do 5 add 3, which is 18, isn't it? Okay? So we've got 18 over 21, and that must go into the blue box. So we've got 18 over 21. Now again, I bet this question throws lots and lots of pupils, but very, very simply, by having a habit and a routine of just rewriting the question and then knowing that we're going to then rewrite the question again below with the new numerators and denominators, etc., we can just go through a process that we don't need to worry about, and we get the answer within 15 seconds, 15, 20 seconds. Absolutely perfect. Here's another question. Okay, so again, very common. If you want to, the autopilot can start here. 5, 10, 15, 20, 4, 8, 12, 16, 20. Okay, now again, if you're familiar with your times tables, which you should be, we should see 5 and 4 and know that it's going to be 20. Again, autopilot, let's go. 1 over 5, add 3 over 4. Rewrite the question below, add equals. We know that we're working with 20ths, so I'm just going to write them in. And then it's all down to the adjustment. So how do I get 5 to 20? Well, it's times 4. So I'm going to times the numerator by 4, which is 4. How do I get 4 to 20? Well, it's times 5, isn't it? So I'm going to do 3 times 5, which is 15. So that leaves me in a position of green light status, which I quite like. Let's just do 4 add 15, which is 19. Again, 19 over 20. Mark done. And again, here's another one. When you see straight away that they're in the same times table, one of these fractions isn't going to change. The larger one isn't going to change. The one with the larger denominator. So again, if we write these two times tables out, we've got the 9 times table, and then we've got 3, 6, 9. 9 is going to be our common denominator. Again, you don't need to write these out. If it helps, you can. So again, 4 over 9, add 2 over 3. We know that we're going to be working with ninths, so we're sort of in autopilot mode here a little bit, equals, and we're working with ninths. Now again, this is already a ninth, so there's nothing that needs to change with this fraction, which is perfect. And then we're thinking, right, how do I get 3 to 9? How did 3 change to 9? Well, we multiplied it by 3, didn't we? Okay, so we need to multiply the numerator by 3, so 2 times 3 is 6. Very simple. And then we have 4 add 6, which is 10 over 9. Now, again, you would get 10 over 9, but we want to get into the habit of converting this improper fraction to a mixed number. And again, remember to do that, we just divide this number into this number. How many 9s are in 10? Well, there's 1, isn't there? And if there's 1, that means we've got to 9. Count on to 10, there's 1 remainder. So it's 1 and 1/9. Okay, if you put that in, you would get the mark as well. But 10 over 9 gets you the mark, even as an improper fraction. What it is worth noting, though, as I've just pressed record again there, when it comes to the reasoning paper, you may have some similar type questions, but the written question might ask you to answer as an improper fraction. So that's where you need to consider that it's not just blindly answering as an improper fraction. It might be that in one of the reasoning questions, you end up with an improper fraction, but then the question asks you to answer in a mixed number. So that's why this skill is important, being able to convert. And it's dead simple. It's how many 9s are in 10? It's clearly only 1. And again, if I visualize that, we've got 10, haven't we? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. How many 9s are in there? Well, there's 1. That is a whole. And then there's 1/9 remainder. So it's 1 and 1/9. All right. So having that skill is important, especially when it comes to the reasoning paper, because there are questions that crop up that ask you to answer in a specific way, and it does that on purpose because it wants to see if you can convert from an improper fraction to a mixed number and vice versa. So let's have a little bit of a look at this one. This is a good example of where there's a little bit more work to do because the denominator isn't a low one, basically. So ultimately, when we have 9 and 4, the denominator is quite high. So I'm going to show you that. So we've got 9, 18, 27, 36. Now, the only number there straight away that jumps into my head out of all those is 36, because I know that's 9 times 4. But just to prove it to you, if we went through the 4s, we've got 4, 8, 12, 16, 20, 24. We still haven't got a match. 28, still haven't got a match. 32, 36. So we know, and again, my top tip would be, we don't want to spend too much time on this. So if the old adage again there, if we look at this and go 9 times 4, 9 times 4 is 36. So if you multiply your denominators together, you will get a common denominator. You will get one. It just might not be the lowest one that we want, because there are other examples lots of examples where we can find a smaller denominator, and that makes things easier. So if you are stuck, you can just multiply these two together, and that will give you a denominator. All right. So let's just dive straight into it. We've got our common denominator, because again, we said that we're ready to roll. So let's just go. So we've got 8 over 9, take away 1 over 4. Rewrite the question below as a subtraction. And again, this isn't taking any time. 36, 36, 36. Let's get on with it. How many 9s to get to 36? Well, it's times 4. So 8 times 4 is 32. How many 4s to get to 36? Well, that's times 9. 9 times 1 is 9. So then from there, we can do the subtraction. 32 take away 9 is 23. So dead simple, 23 over 36. And that would get us the mark. So again, with that one, you've got to do a little bit more work, because basically people are going to go wrong here. They're going to make a mistake here or somewhere in here, and then this doesn't match up. But again, if you feel like all of a sudden you're trying to do this, and let's say you spent 15, 20 seconds on it, and you're still not sure, just multiply the numerators together, and you will get a denominator regardless. Okay, it may be a high one, but that's fine. All right. So for example, if you had 4 and 8 as denominators, okay, so I'll show you this. 4 and 8, let's just say they were the denominators. If you just got into the habit of multiplying together, 4 times 8 is 32, you would end up with 32 as a denominator. And as a result, the numerators would be much higher. Like this one, the numerators were much higher to work with, which can cause problems. Whereas really, the lowest common denominator of 4 and 8 up here is just 8, isn't it? 4, 8, and then 8. All right? So just multiplying them isn't an effective strategy, because you will always end up, or in a lot of cases, you will end up with a really high denominator. And we can avoid that in lots of instances by just thinking logically and going, right, what's the lowest common denominator of 4 and 8? Well, that's 8, isn't it? So you're making life easier for yourself. And again, this one is potentially a little bit of a mean one, because again, it's not. So again, you could just go into that autopilot of times them together. 7 times 9 is 63. Because if you do the 7 times table and you know your 9s, you got 7, 14, 21, 28, 35, 42, 49. We still haven't got to something that I know is in the 9 times table. 9, 18, 27, 36. So it might be that you get to this point and just go, I'm just going to multiply the denominators together. All right. Ultimately, it is what we think it's going to be. And we've got 45, 54, 63. And again, over here, we've got 49, 56, 63. So we end up in that position of having 63. So sometimes it's just working out with some of them. And again, it's experience. If you practice with lots of these questions and you see 7 and 9, you just know that the denominator is going to be 63, because there's no other common multiple in there. Once you've got it, again, it's just straight into autopilot, because we've used up quite a lot of time working this out. If you've done it this way, if you've just multiplied the denominators together, that's a quicker way in this instance to just be at 2 over 7, take away 1 over 9. Rewrite the question below. We're working with 63 as a denominator, but the good thing is it's in where we want it to be. And again, because the denominator is quite high, we're going to end up doing larger multiplications. How do I get 7 to 63? Well, if you'd written it out, you can work it like this. So you've got 1, 2, 3, 4, 5, 6, 7, 8, 9. 7, times 9 is 63. So 2 times 9 is 18. And then we've got, how do I get 9 to 63? Well, again, 1, 2, 3, 4, 5, 6, 7. Okay, but if you know your times tables, you can do that quite quickly. 7 times 1 is 7. 18, and now we're in the position to answer the question. 18 take away 7 is 11. So we've got 11 over 63. So again, that's the last example, but it's a bit of a stinker. And again, question 31, you would be encountering this question right at the end of your half an hour. Okay, you've probably in and around a long division or a multiplication. So the reason why, you know it's going to have a little bit more complexity to it because it's right at the end of the paper. All right. So again, another little tip with the SATs papers is that they do tend to get progressively more difficult. First 10 or so questions, we should be looking to smash them out in 3 or 4 minutes because they're all dead simple. As you go through the paper, you're going to encounter more complex questions that need a little bit more working out. And finally, welcome to the fractions party, which hopefully makes fractions sound more enjoyable. But so yeah, this is just to finish with. So again, some fractions questions. So we've got some additions, and then we've got some subtractions. Very straightforward. But again, have a go at these. Start with your addition, and again, just get into the habit as you do it. Just go, what do I notice? Just ask yourself that question before, even though you know they're different, are the denominators the same or different? Yeah, they're different. Right, I need to go through the process. What's the common denominator? Ask yourself that question every time. What's the common denominator? What's the common denominator? What's the common denominator? All right, get into that habit, because as soon as you see fractions that have different denominators, the first thing that you have to do is find a common denominator, okay? And ideally, the lowest common multiple. Yes, if you're really stuck, you can multiply them together, okay? But like I say here, if you did that, if you just multiplied them 3 times 6, you're going to work with 18, whereas actually, the lowest common multiple of 3 and 6 is 6, isn't it? So you can work with a much lower number, which means when you multiply shortly, the numerators will be smaller. So you're giving yourself a break and you're making things easier for yourself. So ultimately, that's fractions. And again, master this and you're guaranteeing yourself 3, 4, 5, maybe even 6 or 7 marks in your SATs papers, because when you do the practice papers at school or you download some online, there's always loads of these questions in the papers and they are easy marks to pick up using this strategy. So get practicing and get those marks. So another huge week in terms of teaching content. Now, I really do hope that after watching that, you feel much more confident about adding and subtracting fractions with different denominators. And it's definitely about practice. We want to get to that green situation and go with the same denominators. You must know your times tables because those multiples are absolutely key to you being successful and adjusting those fractions so that the denominators are common. We want that common denominator. But it's very, very simple to do. And again, going right back to week 1, if we just have a simple attitude towards presenting, just quickly rewrite the question and then rewrite the question again below, it's going to take 10, 15 seconds to answer the question and we've got the mark very, very confidently and we can move on to the next question. And the best thing about these, I love these questions because there's so many marks available. Okay, you're probably going to get 4, 5, 6, maybe even 7 of these questions in your arithmetic test. So for me, it's easy marks if we've got this strategy. As I always say, get your hands on a copy of SATs Like a Ninja. All of the content in these videos and much, much more is in this book, available in the link. And finally, as to finish, please make sure that you subscribe. That's going to be somewhere around here. Subscribing to the channel really helps me make more content for you guys and help more and more children with their SATs. So please subscribe to the channel and please like the videos. Please leave some comments. And ultimately, go away and practice a little bit more and you will be ultimately then ready to smash your SATs in a few weeks' time. So well done, keep working hard and your SATs will be an absolute breeze as a result.